Now let's talk about the reversed heat engine. Now since all the processes of a Carnot cycle are reversible, it is possible to imagine that the processes are individually reversed and carried out in a reverse order. So if you look at this diagram, this is a cyclic process which is happening between two temperature reservoirs. So again we assume that T1 is greater than T2. Okay, now this is a heat engine which is individually reversed. All the processes are reversed. In a heat engine you get some work output from the turbine, but in this is in the reverse direction. If it was a conventional heat engine, then this direction would have been this, in this direction. Okay, but now it is reversed. Similarly, if you look at the pump, now pump is it is an energy consumption device. It is not able to give you some work output, but in this case that work input is reversed and shown as a work output, that is WP coming out of the pump. Okay, so this is reversing each and every process individually. Alright, and if you look at this, if this was a cyclic heat engine, then the flow of heat would happen from temperature T1, but now the flow of heat is out of this heat exchanger into this energy reservoir, and you are absorbing heat from the heat sink, that is Q2. So each and every process is reversed in a reversible Carnot cycle, and therefore it becomes a reversible heat engine. Okay, now if you come to this portion of the video in which we have two diagrams, and this diagram depicts an engine, and this engine is represented by the letter capital E, and in a similar way or in an analogous way, this is a reversed engine. This is a reversed engine, alright, which might be a refrigerator or a heat pump. It is represented in this way. It is reversed. So E is flipped and becomes reverse. So this is a reversed engine. Now, if you pay attention to the engine, you have heat coming in from the heat source and heat being rejected to the heat sink. The pump work is the input work, and you get the turbine work as the output work, and the net work output is W net is equal to WT minus WP. Alright, but in this case, if you look at the reversed heat engine, so this is the reversed heat engine. Alright, you are absorbing heat from the low temperature energy reservoir and rejecting heat at high temperature reservoir, and the output work is now reversed and fed into the heat engine as input, and the input work is now reversed and taken out as output from the reversed engine. Again, the net work input, in this case it is input, would be equal to WT minus WP. So this is a concept of a reversed heat engine. Now a reversed heat engine can be either a heat pump, alright, or it could be a refrigerator. Alright, so this is a very basic and a very easy concept to understand. That is, when you reverse individual processes in a reversible Carnot cycle, you get a reversed Carnot engine or a reversed Carnot cycle. Okay, now after having talked about the reversed heat engine or the reversed Carnot cycle, let's now pay attention to a very important topic in the Carnot cycles subtopic, that is, we'll talk about Carnot's theorem in the next video. So let's go to the next video and study Carnot's theorem.